All right, how are you doing? We're going to get going here with a parallel circuit. So we're going to start breaking down a very simple parallel circuit given the voltage and the resistor or the resistance at each resistor. That's a mouthful. Okay. Um, so when I look at this, my first step is going to, write down what are my knows and my need to knows. Okay. So I always have this that I give my kids for them to fill out. We're going to look at here and I say, okay, well, I've got my voltage total, so I can fill that out, 9.3 volts. And I have my resistor value at each resistor. So resistor 1 is 330 ohms. And then I have 1.2 kilo ohms. I'm going to go ahead and convert that into the base unit. So that's 1200 ohms. And then I have 470 ohms. Now, when I look at this, that's all the information that I'm given. And so now I have to start using Ohm's law or some of the formulas that we know about parallel circuits to kind of fill in the blanks. So when I look at this, I say, okay, well, what can I do? Well, I have all of the resistors, so I can find the resistance total. So step one, and I'm going to kind of just write that over here, is we're going to write down kind of these steps. And I'm going to say step one is going to be to find the resistance total. And then behind here, I have kind of just my formulas for stuff in a parallel. And then from the last video, I have the ones from the series there. I look at this formula. This is the one that Project Lead the Way gives us to use, and I'm fine with that. I also want to say here's an easier way, if you guys can see that, to do that. And I'm going to work it both ways just so you see that. So when I grab my calculator, I'm gonna do this method up top first, this guy here, and so we can look at that. And I'm gonna, just like I tell my kids in class, I like parentheses. They're like little math hugs. So when in doubt, parenthesis it out is my saying. Copyright 2010. All right, so I'm gonna go parentheses 1. Parentheses, okay, divided by parentheses, parentheses. Remember, I'm doing this guy right here, this formula, 1 divided by all these 1s over the R1s. Now, I'm going to say 1 divided by resistor 1, which is 330, close parentheses, plus, open parentheses, 1 divided by the next one, which is 1200, parentheses, plus, open parentheses, 1 divided by my third resistor, 470, parentheses. Now I've got to close the parentheses. When I hit this, the rule is, if I'm going to say, does this make sense? Remember, my resistance total in parallel has to be less than the least. Let's see what we did. That is less than the least, 166. So that checks out. Does it make sense? Yes, it does. Passes the old sniff test. So we'll go 166 point. Let's write down a couple of decimal places there, 90. And that'll be our resistance total. So I wanted to quickly show you the other way, which is here. Okay. So let's look at that. And I can go parentheses. And our first resistor value was 330. And we're going to go -1 plus our next one is 1200, -1, 470, -1. Oops, I forgot my plus. Plus 470, -1, -1. Same number, if you can see that. So the exact same, 2 different ways to get to Walmart. They both work just fine. So I found my resistance total. Now, what can I do next? Well, looking at these guys over here, well, which one of those formulas can I do next? Well, I can use Ohm's law. I've got 2 of 3 things in that triangle. So when I look at this Ohm's law triangle, voltage and resistance, I can solve for current. So voltage divided by resistance is going to give me the current. So I'm going to take my calculator here, and I'm going to say 9.3 divided by 166.9. And that gives me this number, and I'm going to say, does that make sense? What's my check? What should I be answering? Is it a small number? And all the circuits I'm going to give you in class, or most any electrical circuit, the amperage is going to be much smaller than the voltage, much smaller than the resistance. And I look there and I go, oh, it's only 0.05. That checks out, okay? So I'm going to write that down. 5.7, and we'll put a subscript A there for amps. All right, so I've got that guy. Now I can look and I go, okay, well, what can I do? What can I do next? Well, let's look back over here at my formulas, and I can go, oh, look at voltage. In a parallel circuit, my voltage is always the same, okay? And I could have done this first too. So step 2, let's say use Ohm's law to find IT. We'll say step 3 is find the voltage at each resistor. I'm just kind of shorthanding that. All right, so I can just say all of these are the same, 9.3, 9.3, 9.3, and I could add the little V there for volts if I wanted to put the unit, which is nice. Now, last thing, I just have the current. Well, what's my current rule? What's my current formula? Well, remember the current, okay, is the sum, the total is the sum of the parts. So I have to find all of these currents I can't, they're not the same like they were in a series. They're the sum of the parts. So I look at that and I go, okay, well, what can I do? I've got voltage and I've got resistance at each resistor. So I can use my Ohm's law again to find that. So when I look here to find current, once again, I'm voltage divided by resistance. So I'm just going to come across here at each one of these guys, and I'm going to say 9.3 divided by 330. Remember, this should be a small number. Broke my pencil lead there. I'm going to switch to pen. 0.02818. I'm going to keep a couple decimal places here. Move to the next one, 9.3 divided by 1200. And we'll go 0.00775. Next one, 9.3 divided by 470 is 0.01978. And I look at that and I go, well, do those answers make sense? A, they're smaller than, they're this kind of small. And then I go, well, look at the biggest resistor here, 0, 0. That's the least amount of current. Well, the more resistance, the less current. That makes sense, right? So I'm kind of seeing that those numbers make a little bit of sense. Okay, now I can double check that, and that's why I kept the 4 decimal places there, or at least or not really 4 decimal places, but 4 numbers in each one, and I can kind of add all these back up. So now I'm going to look over here and I'm going to say this Kirchhoff's current law, and I kind of have this note here. I'm going to add those up. So I'm going to come here and I'm going to say 0.02818 plus 0.00775 plus 0.01978. And when I hit the enter button here, it should be very, very close to that number there. Oh, man. I love it when a plan comes together. So that checks out, 0.5571. Oh, so we needed to finish writing down our steps. 4 was to use Ohm's law to find current at each resistor. 5, discount double check using Kirchhoff's current law. There you go.